Good morning, everyone. My name is Jun Xiaohan, a PhD candidate from Zhejiang University. Today, I will present my paper named An Empirical Study of the Dependency Networks of Deep Learning Libraries. As we all know, deep learning libraries are crucial for the development of deep learning software projects, which can save the effort related to the implementation of deep learning algorithms. Nowadays, there have existed many popular deep learning libraries. Due to the popularity, deep learning libraries have been widely used in various domains. Deep learning libraries can save users' effort and have gained tremendous traction from various application domains. Deep learning libraries are constantly evolving to add new features, fix bugs, and so on. Therefore, to take full advantage of deep learning libraries, users should always keep pace with the latest versions of deep learning libraries. Aptly managing the versions of deep learning libraries can help projects avoid crashes or security issues caused by deep learning libraries. In this paper, we choose Tensorflow, PyTorch, and Theano to perform our study. The three deep learning libraries are atypical and widely used in deep learning domain. Our goal is to solve these four research questions. AQ1, what are the purposes and applications of deep learning projects that depend on TensorFlow, PyTorch, and Theano? AQ2, to what extent do deep learning projects depend on TensorFlow, PyTorch, and Theano? AQ3, how are the update behaviors of deep learning projects that depend on TensorFlow, PyTorch, and Theano? AQ4, how often do deep learning projects use the latest versions of TensorFlow, PyTorch, and Theano? To achieve this, we extracted open source projects in GitHub that belong to the used by list of TensorFlow, PyTorch, and Theano via the dependency graph provided by GitHub API. As a result, we obtained all projects that depend on TensorFlow, PyTorch, and Theano. Then, we filtered the projects and extracted sample projects to study in the rest of the paper. Our methodology includes three parts: category classification for AQ1, dependency extent for AQ2, and version analysis for AQ3 and AQ4. We first introduce part 1, category classification. We determine the purpose categories and application domains of studied projects by the card sorting approach. After classification and labeling, we have 5 purposes and 13 application domains. Then, we try to determine to what extent deep learning projects depend on deep learning libraries by checking the import statement. If there exists at least one import statement of deep learning libraries in deep learning programs, we defined it as a direct dependence. Otherwise, we defined it as a transitive dependence. In this way, we obtained the dependency extent of deep learning projects. Finally, to record the historical dependency changes of deep learning projects towards deep learning libraries, we analyzed their update behaviors and the distribution of dependency versions. We analyzed the update behaviors from 3 aspects, including the type of version changes, the update reasons, and the update time lags. Now, we introduce the results in this part. We introduce our findings for AQ1 first. This is the distribution of purpose categories. We notice that TensorFlow-dependent projects concentrate more on software development, while PyTorch-dependent projects concentrate more on paper experiments. This finding is in line with the previous study that TensorFlow does well in industrial production capabilities, while PyTorch deeply plots the research community. After that, we display the findings for AQ2. This figure shows the distribution of the direct and transitive dependencies of projects that depend on TensorFlow, PyTorch, and Theano. We can find that all deep learning projects have a higher proportion of direct dependencies than transitive dependencies, while PyTorch-dependent projects show a much lower ratio of transitive dependencies compared to TensorFlow and Theano-dependent projects. Next, we review our findings for AQ3. Our findings reveal that there exist 3 types of version changes: upgrade, downgrade, and no change. Only a small percentage of projects have upgraded or downgraded deep learning libraries. Most projects have no change with their deep learning libraries. To explore the upgrade and downgrade reasons, we manually analyzed the commits of these deep learning projects. Here we listed some upgrade reasons for TensorFlow, including addressing critical severity vulnerability, upgrading to ensure their TensorFlow version less than 2.0, and upgrading the TensorFlow version to make it compatible with existing frameworks or libraries, and so on. There also exist some other upgrade reasons for PyTorch. For more detail, please refer to our paper. We also computed the update time lag and release time lag and find that, on average, the update time lag of TensorFlow-dependent projects is longer than PyTorch-dependent and Theano-dependent projects, while the release time lag of Theano-dependent projects is longer than TensorFlow-dependent and PyTorch-dependent projects. Finally, we come to the findings for IQ4. These are the version distributions of TensorFlow, PyTorch, and Theano. We can notice that Theano-dependent projects had the highest percentage of the latest versions compared to TensorFlow-dependent and PyTorch-dependent projects. One reasonable explanation may be attributed to that TensorFlow and PyTorch have way more versions and are releasing new versions frequently. More versions lead to more choices, and the newest versions are apt to exist big API changes or compatibility issues. Thus, users are prone to select a recent but not the latest version to avoid various unexpected problems. In this paper, we investigated to identify the purposes and applications, dependency extent and update behaviors, as well as dependency versions of deep learning projects that depend on TensorFlow, PyTorch, and Theano. There exist some commonalities as for the purpose distributions, application distributions, and dependency extents of TensorFlow-dependent, PyTorch-dependent, and Theano-dependent projects. There also have some discrepancies as for the update behaviors, update reasons, update time lag, and dependency version distributions for such projects. In the future, we plan to study more deep learning libraries and encompass proprietary projects to expand the generalization of our results. Moreover, we also tend to deeply explore existing research questions and analyze more additional questions related to the dependency networks of deep learning libraries, such as to analyze and compare direct and transitive dependencies thoroughly. That's all. Thank you.